I'm Elliot Zerker.
I'm Nick Blanchard.
And I'm Gavin Caldwell, and we're going to take you a little bit under the hood to look at our code implementation, as well as demonstrate to you a user experience on the front end.
Alright, so now I'm going to talk about the code running on the embedded particle device. So at the top here, we got the libraries we're using. We're using the particle.h library, the max30105 library, heart rate, and SpO2 algorithm. These are all from SparkFun, and the Arduino library. Next, we have the definitions and function declarations. These are the functions that you're going to see in a little bit. Below that, we have the global variable declarations. We chose to mostly utilize global variables because that lets the compiler know how much memory to allocate ahead of time, so we can avoid pesky memory errors later. Down here, this is pretty important. This is a struct that allows us to store data to be transmitted at a later time if we don't have internet. Here's an object that allows us to do some LED control. And this is probably the most important part, the synchronous state machine. It has 4 states: waiting state, which is like an idle state, request measurement state, take measurement state, and post measurement state. So getting into the functions, here is a callback function that runs when we receive updated parameters for the device. So what happens is this function gets called whenever we want to update the acceptable range for measurements, as well as the measurement rate. So it's a lot of code. It's actually relatively simple. It just parses that data that we're getting back and extracts the number for the starting range, the ending range, and the rate. The reason there is so much code is because it's a C character array, and you have to iterate through every single character to figure out which ones you want to keep. This function down here, the return string, is just a helper function for what we were just talking about. It just returns the numbers that you want from a string. So here's the setup function. We begin the serial monitor. We set up our sensor using the SparkFun libraries. We do our particle.subscribes. This is what allows us to get data back from the particle API. And we turn the LED on. Next, we get into the loop function. This is the most important part. This is where we implement the state machine. So if we're in state 0, which is the idle state, we check for updated parameters. We update the starting range, the ending range, and the measurement rate. We update the current time, and we check. If our current time is within the acceptable range that's set by the user, and it's been long enough since the last measurement, then we'll transition to the next state, which is preparing to take a measurement state. If that's not met, then we stay in this current state, wait 2 seconds, and just continue in that cycle. So the next state is the requesting measurement state. What happens here is we enable the LED to be blinking blue, as it should be, and we go to the next state, which is the taking the measurement state. So in the taking the measurement state, what this code right here is doing is it's taking samples from the sensor and calculating heart rate and blood oxygen saturation. So we check if the numbers for heart rate and blood oxygen saturation are valid, and if they are, and it's been less than 5 minutes that we've been trying to take a measurement, we go to the next state, the final state, which is the transmitting state. Here, we have a string that stores all the data we want to send. We send it to our particle API using particle.publish. If it's a success, update the LED to show it was a success. It'll break it green. Otherwise, update the LED to break it yellow to show it was not a success. So, if it was not a success, then we save that data in the buffer to be transmitted later. Now, stored data is transmitted directly after we try to transmit data the first time. So you can see up here, we send our data, update the LEDs, and then we try to send our backed up data. So we go through all of the data in the buffer and try to send it. So every time we're in the transmit stage, we're not only transmitting a current data point, but also checking if there's stored data points that we can try to send as well. And that's all the embedded code. Thank you.
Hi, Elliot Zerker here. I'd like to talk now about our backend and web server implementation that we have running on our Amazon Web Services. So start here with our app.js. This is our main entry point. So we include all the node modules that we use for this project, including the routers that connect to our endpoints. Then we create our node app, hook up any middleware that we plan to use for this project, connect our routers so that the user has access to all the endpoints. We also have a little special function just for catching and handling 404 errors in a pretty way. And finally, the HTTPS create server creates our server that's running on HTTPS. Currently, it's just using a self-signed certificate. A more robust implementation would definitely be using a certificate signed by a valid authenticator. Our db.js, this JavaScript file just has a quick connection to our local instance of MongoDB, in this case running on Amazon Web Services. So this is where we store all our data. Then going through these folders one at a time. In the keys folder, we've got key files relating to the HTTPS certification. We store these all in here, as well as the JOT keys. So these are the secret keys used to encode our JOT tokens that we'll use for authentication later. All these are stored here in the keys folder. In our models folder, we have 3 different models, or 3 different kinds of objects that will be stored in our database. First is the device object. So here you can see every device has a unique ID, an API key. The rate is the frequency at which measurements should be taken. Range starts, the time of day that measurements should begin to be taken. Range end is the time of day at which the device will no longer ask for readings. Then recordings is a list of all the recordings that the device has taken, including a timestamp, the heart rate, and the blood oxygen saturation level. Our physician.js, here's our schema and object for the physician object. Pretty simple, just has a name, an email, and a password. And our user object, also very similar to the physician with a couple of additional things. Users, in addition to having their full name, email, and password, also have a physician assigned to them, as well as a list of devices that they own. So those are our models. Our node modules, of course. In our public folder, we have Bootstrap hosted locally here in our Bootstrap folder for styling. Images contain all the images on our website, namely those profile pictures. JavaScripts, now this contains all the JavaScripts that run on the front end. These make, for example, the AJAX calls to the back end, which we'll go into detail later. I'll just open one of these to give an example. Most of them are very similar to each other, but you can see, for example, that after the window is ready, has been created, it makes an AJAX call to get user data, and this will populate the data on the page, in this case the physician page, the select physician page. So these are the sorts of calls that go on the front end. You can see just AJAX and then callback functions when you're done, as well as registering click handlers on the various buttons on our front end. jQuery also hosted locally, so we have that in that folder. Physicians, we have a hierarchy of our HTML pages, so this folder contains all HTML pages that should be viewed only by physicians. Plotly, this is the plot library that we are using in JavaScript for plotting user data or the sensor data on the user's graphs. Popper.js, this is just a dependency. And then style sheets, this is some custom styling that we added to the different pages to give it some nice coloring. So home.css applies style to most of our main pages, then login.cs and physician.css and user.css just apply the styles to the different HTML pages that use them. In the users, again, these are HTML pages that should be hidden behind token authentication that only the user can see. And then we have some remaining HTML pages. These are public and can be seen by any user, authenticated or not. These are things like the home page or the references page. So that's our public folder. Our routes folder, device.js. This contains all the routes pertaining to the device. So any routes dealing with the device are handled in this file. So first we load in both the physician and user keys. JOT keys, that is. That's because both physicians and users will be using the devices. So in some cases we need to authenticate either one. The router object, and then this unique function here just generates API keys when the user registers a new device. Register a new device, this is the endpoint that allows the user to register a new IoT device to collect sensor data. So you can see, because this is a protected endpoint, it checks for the XAuth header, which contains the JOT web token. Should be coming from the user in this case, so we decode it using the user key. Then here quickly, there's a quick safety check to see if the device already exists in the database, because we don't want multiple users to be able to register the same device, otherwise users will be able to see each other's data, which would not be good. Lack of privacy. And then after that, it updates the database and adds the new user, or adds the new device, excuse me. Then our delete device endpoint, another step on our CRUD implementation. Again, also checking for that XAuth header to make sure that it's an authenticated user. Very similar stuff going on. Update device, this is used to update those device parameters that determine when the device asks for measurements and how often it asks for measurements. This is a good example of one that both the user and the physicians have to be able to access, so it checks for both. Read device just returns the device so that the user can pull any information regarding the device, for example, all the measurements that the device has used for plotting. Pull parameters front, this is used to pull the device parameters to the front end. Those parameters previously mentioned, like the measurement period and frequency. Record reading, this is the endpoint that hooks up with our AWS integration and Particle Cloud, allows the device to store readings in the database. And so you can see we're doing some formatting with the date here to get an accurate timestamp. And then this particular endpoint is interesting because it doesn't create a new device in the database, but it pushes a new recording to that device's list of readings. And then pull parameters, this is how the device updates the new parameters that it receives when the user updates the parameters from the front end. Index.js, this is a real quick one. This is just a router that redirects the user in case they enter in our generic domain name. They'll get taken to the index page. Physician.js, so this is the router that deals with all endpoints related to the physicians. So you can see we're reading in the physician key. Then create physician, this is the endpoint that allows the creation of a new physician account. You can see it checks if the particular username has already been used, then it sends back an error so that we can't have multiple physicians in the database with the same username. Login physician allows this is where the physician has entered their credentials, and it will create a JOT token using that physician key and send it back. That token can then be used for all future authentication. Get physician data, this is another example of a protected endpoint, so it checks for the physician's token in the header, just returns the physician object queried. Update physician data. Physician get all patient data, this endpoint is used so the physician can query the data for all the patients that they see. And physician get single patient data, used so that the physician can query data for a single patient. And finally, user.js. This is very similar to the physician.js, but for the users. So we're reading in the user key, create user, login user, get user data works all the same, update user data. This is new, list physicians. This is for the requirement where the user has to be able to select a physician, so they need an endpoint to be able to query the database and list all the physicians there. And then assign physician. This is how the user can select a physician, and once done so, it will be the user's physician field will be set to that physician's name using this function here. And that is our backend and our backend setup and our front-end web server.
Hi, how's it going? This is Gavin here. I was in charge of developing the front end for this project, and I'm going to take you through our Heart Tracker web application and then talk you through a little bit of the features and demonstrate the functionality. Important details to say is that we used the popular framework of Bootstrap to develop this front end. It gives some really helpful styling tools and utilities that make it development time significantly shorter. We chose specifically Bootstrap version 4 for this project, and the reason we chose that is because it allows us to still utilize jQuery in our JavaScript, which is really, really handy. I'll show you another plugin we use called Plotly that helps us demonstrate that helps us plot our visual data. So I'll just go in right ahead and do a little patient sign in here. As you notice, you also have a create account function where you input your full name, username, and password. But we'll go back to our patient login and log in as Mario. And important thing to note is that there is, hold on, I gotta count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is data validation on this login form. You have at least 10 characters, 1 capital letter, and an extra, and a number. So with that, we'll go ahead and sign in, which will bring us to our main landing page. This is the user data view. We start by default seeing our weekly summary data for our beats per minute, our heart rate. So over the past 7 days, our average heart rate was 156. Our minimum was 34, and our max was 250. We can use this view selector here. I wonder if I can move this. We have this view selector here that can change the day of the week that we want to look for. So if I wanted to look at Monday's individual specific data, then we see our Plotly plugin coming into effect here with this really nice generated plot for us, which we can investigate individual points and hover over them and see even more information about the data, a little bit more specific. So what is the value and what was the exact timestamp? And we see a similar thing going on here for the blood oxygen saturation level. With that, we'll move on to the Register Device tab. Here we can manage our devices and add new ones as we see fit. We have a little tooltip here that shows how this page works. So if I click on our device test here, we see that we can edit the rate of measurement, the start time, and the end time. Important things to note here is that we actually do have some data validation on this. So for example, let's change this to 2 p.m. and try to make our start time at 10 a.m. It's not going to like that. We can't have an end time before our start time. Similarly, if we do an end time of 2:30 and I do a rate of measurement of 45 minutes, it's not going to like this either. Oh, I still have it on set to 2 p.m., but it's not gonna like this either. We can't have the rate of measurement be larger than the time span of a lot of measurements. That doesn't really make much sense. So let's bump this back up to, as well as there's data validation on the form entry is here. I can't enter an invalid number like that. So let's bump this back to 5:30 p.m. with 45 minutes and save that, and that went through just fine. I can add new devices here as well. So let's add a couple new devices, and it will check if there is a device already in the database. So that will kick us out and not let us do it. There can only be one device. One device can only be associated with one user. So once it's in the database, it can't really be impacted anyway else or used anyway else. So let's add another register here. And so we see that our page is populated with those, and we can edit those device parameters as well. But if we click these X's here, then we can go ahead and remove them. Let's move on to select physician. Let's move on to select physician. So here we see we have our current list of physicians here, or our current physician as well as the available physicians. And it's simple as clicking on one and it will swap them out and will update everyone's respective database accordingly. Let's go back to Daniel Reynaldo because we're going to need him later on. So then we go here to our health summary again. And now I'll show you the account info page where we can edit our account. So let's choose a new full name that isn't so silly. Confirm changes there. Account updated successfully. The page will reload and we see that there. We also can update our password, which I can show here, but I'm not going to do that because that is tedious. Either way, that's all the functionality we have here for the patient. So let's log out. And now we're going to log in as our physician that I was mentioning earlier. So we have Daniel@gmail.com. His password is 1235789 with a capital O. We're going to sign in. And now we get to the patient home view. From here, we can do a couple things. We can't do much yet because we haven't actually selected a user, right? So these are just going to come up as blank plots. So we come back here, there's nothing. However, if we go to viewing modified patients, we can see a list of patients here. So let's go ahead and view Mario's. And from here, we can choose Mario's weekly view, which we'll see we have the exact same values as before, which is really cool. We can also go to his singular view, which will give us the same data we saw on the user's front side. And then finally, we can modify Mario's device parameters. Now, physicians can't alter the time of measurement, but we can alter the rate. So let's change Mario's rate of measurement to 15 on our end, and we'll say the device parameters updated successfully. So close that out. We have a similar account info screen here where we can change Daniel's name and his password. But let's just do one last check and log out here and then move into the patient sign-in, which we will do for Mario one more time. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we should see now, what did I do? Okay, hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. RIO1. Sign in. There we go. We should see as we move to our registered devices and look at test that our rate of measurements has been updated on our end. So that is that's a good overview and total summary of the functionality of our website here. And just one more look at the index, which has the developers involved in this project, as well as a reference of some of the node modules and front-end frameworks and IoT device libraries we used. So thank you so much.
All right, so here we are in the idle state for the device. You can tell from the breathing green light that it's waiting to meet the conditions to take a measurement. So now, as you can tell by the blinking blue light, we're in the state where it's trying to take a measurement. So I'll place my finger on the device, and you can see it successfully took a measurement. So it flashed green, and now it's back in the idle state.
Okay, cool.
So we're in the measurement state again, but this time we do not have Wi-Fi. So we'll see that when we take a measurement, it's going to flash yellow, indicating that it failed to send the data to the web server.